I'm going to present you my work about supply chain sustainability, hoping that you can also see the content of the slides. My part is about a real case study on dairy industry and about what we have done in conducting supply chain carbon footprint assessment and enhancement in a real situation of manufacturing context. My name is Pietro Negri. I work as a consultant at asset consulting company. I have previous experience also in other consulting companies, and I mainly do simulation and also supply chain and operation related projects, which in the last years have also been increased in their value proposition also by this new dimension of sustainability, which thanks to simulation I'm now able to include in my working portfolio. So getting to the case study, just to briefly gives you some details. We are talking about the dairy industry in Italy. The case study is located in Italy 4 years ago. And we, for sake of simplicity, we are just analyzing one product, which is simple white yogurt. So very simple dairy product. The objectives were multiple. First of all, we have to do a total carbon footprint assessment, embracing all three scopes as the GHG protocol has stated to include in the non-financial disclosure of companies. Then later on, we have an objective of decarbonization strategy development. So setting and defining which could be the possibilities, the alternatives for the company in this case to follow in order to decarbonize its own operation and possibly reach net zero in the future. And for sure, we have also focus on financial, because as most of you may know, sustainability sometimes is a cost, some other times is an opportunity. So we have to keep financials under the lens, and we have to also assure that financial could be enhanced by this kind of project, which mainly has to do with sustainability decisions. For sure, the types of analysis we use is simulation, so the simulation module of anyLogistix, and a few characteristics of the case study were the optimization of the profitability and carbon footprint trade-off, the consideration of hard constraints, such, for example, the shelf life of the final product. And also, one of the greatest difficulty was to select and prioritize the different alternatives over a 5-year time period in order to design what could be the sustainability strategy totally integrated with the financial objectives of the company. So, in order to give you some ideas about how we structured the company we analyzed, we set a perimeter for our analysis starting from the first phase of milk processing, which was made by a supplier, and also from the production of all packaging goods necessary for final production, entailing the jars for the finished product, but also the boxes and cellophane and plastics used for secondary and tertiary logistics. Then we have the core process of industrial yogurt production, which is basically made from milk and other ingredients, which are mixed, and through these detailed production steps are converted in final product. Therefore, the product is distributed in several warehouses located in the Italian territory and serving the retail market. So we end our perimeter of analysis to the retailers. We hypothesized to concentrate those retailers in about 100 points, so 100 possible customers for our model, entailing that we have also to do all calculation about logistics transportation flows from the warehouses to the retailers. As you can see, for each process, we have identified which could be the major impacts on the sustainability performance, which are divided here in 4 categories. So water consumption, energy required for the production processes, potential food waste, and also, for sure, GHG emissions, which were computed according to the IPCC framework. So we considered all possible emission gas from every activity of the supply chain. So we focused starting from the milk production because we have no clue about the upstream flows coming from the farming, let's say, process. So in this way, we will see how the carbon footprint was developed and how it could be developed with anyLogistix or with, let's say, a simulation model. I want to give you this picture because I think simulation is pretty important when dealing with carbon footprint improvement. In this graph, I've clustered the available technologies on the market useful for dealing with sustainability issues. And I've ordered them according to the scope of why you are using such technologies. So what you aim to do with those technologies. So if we, for example, conduct a life cycle analysis, we get very detailed data. We need a lot of time and effort to calculate all the potential aspects of the LCA analysis, but we are limited to a concept of reporting. So just knowing what are the emissions of a specific product or a specific process. So life cycle analysis is difficult to enlarge to the entire spectrum of the company supply chain, company product range, and so on. If we move on to the real reporting phase, we find carbon calculators, which usually use very aggregate data. So, and they adopt, let's say, a black box approach. So we are not sure about how the final emissions were calculated, which were the emission factor used for the carbon calculator, and so on. While if the company has some money to spend, it could evaluate to implement an enterprise carbon management software, which are in fast developing actually. We found the major suppliers of technologies have already deployed their own solutions, but actually for the scope of the activities, those solutions provide just a monitoring and a reporting scope about carbon footprint. So when a company has to deal with improving its carbon footprint, which is the last part of this graph, the real instrument that matters is simulation and digital twins. because, as you may know, it opens the possibility to simulate different scenarios, and so to trace a possible sustainability roadmap that could meet both financial and environmental objectives for the future. So this is the reason why I use anyLogistix for this project. And now we are going to look more in detail at the work that we realized. So here is the model. I hope that it could run. Yes. So this is just a short registration about the model. As you can see, we have quite simple supply chain in which we have also traced an end-of-life point of collection of discarded products. As you know, working in the food industry entails there is always some quantity of product that doesn't come to the shelf. So it expires before getting to the shelf. We use to trace those emissions because those flows, because discarded products represent a waste, both in terms of revenues and sustainability. We use quite all the tables present in the model. So the bill of materials, the production size and batch, where you can see we put different CO2 coefficients retrieved both from the company's researches and also other sources of data which could be considered highly reliable, such, for example, the IPCC database. So we first tested the model without any sustainability performance, and we derived that the model was truly representing the financial and service performance of our company. So therefore, we some kind validated the model with financial data and put also the environmental ones in the anyLogistix model in order to derive both the carbon footprint and the financial performance. So we realized a lot of graphs, as you can see, and the elaboration of data was later on made on an external software, just to provide lump sums, insights, and results for our analysis. And also we use the model to make some scenarios and to make change, so to try different alternatives among the ones chosen by the company in order to give the company management team an idea of what could be the real results achieved, both in terms of CO2 reduction and profitability enhancement. So at the very end, we came up with 3 scenarios, which we let's say we call it a light scenario, a moderate one, and a high scenario, because they have different impacts and they also consider different investment forms. So in one case, in the lighter scenario, we hypothesized to change the plastic packaging jars in favor to cardboard jars. In the moderate scenario, in addition to the packaging changes, we also defined some optimal logistics flow from the factory production facility directly to the consumer. So we, just for certain customers, decided not to use the warehouses in the distribution tier of the supply chain. While in the high scenario, we tried to change the supply chain logic of the company. So we focused on centralization of the stock of final product at company level, in spite of at warehouse level, in order to aggregate stock and reduce the level of discarded products. So as you can see, we traced in this synthetic table both the financial performance measured here in million euros over 5 years simulation period, and the total carbon footprint of the company, which are the first two lines. We have also indication about the products that go to expiration, that expire before reaching the shelf. So we can see that in the first two scenarios, even if they had a good ideas on the paper, at the final end we get a worsening on this performance. So we decided to eliminate them and to concentrate just on the high impact scenario, which is beneficial from several point of views. And at the very end, we also decided to reproduce the overall performance of our scenarios by combining this first two dimensions in a synthetic indicator on the right that we have defined as performance of competitiveness and sustainability, which is the ratios of the tons of CO2 equivalent, so the overall carbon footprint of our company on the value generated. So as you can see, all three scenarios are enhancing the overall performance. But for sure, the third scenario, which is the one with high impact, as the most performing supply chain, because it allows a reduction of around 12% in the overall carbon footprint and an increase in the profitability of around 5%. Getting more in the detail of what we achieved and how, we make a full measurement of the carbon footprint of the third scenario in all possible aspects. So, and we find out that, for example, by changing the inventory policies among the yogurt factory and the distribution centers, we get an overall bullwhip effect, positive bullwhip effect on the supplier side. So as you can see, we didn't change anything in the relation with the milk supplier. We just consume less milk because we produce less expired product. In this way, we have a high impact also on suppliers, so on scope 3 of our value chain, which is something that usually is not in the power of the company to change. So just by looking at optimizing inventories and changing for sure the packaging in order to reduce the carbon footprint associated with plastic in favor to cardboard, we get a double effect. One in the reduction of overall waste, and the other in the reduction of related emissions. So you can see also for what concern the financial performance, which here we call the traditional one, some costs see a reduction, strong reduction. Other costs, for example, the storage ones, have an increase because we have to adapt the factory warehouse. We have to increase the warehouse capacity at the factory and reduce it on the warehouses. In fact, for example, we have 1 million euro in closing costs for the distribution centers. But overall, we get to a final 7% reduction in supply chain costs. And as I mentioned before, a 10% reduction in the carbon footprint of the company. not all the different activities which compose the carbon footprint registered a reduction. We see, for example, in the last flow, the distribution from the factory to retailers increased the overall emission. But quite in all the other parts of the carbon footprint, the emissions are strongly reduced. So this was beneficial. So if we have to some way make a conclusion about this work, what I will state is that we mastered the bullwhip effect and use it to save emissions along the supply chain. We made also an extensive carbon footprint estimation, including most of scope 3 activities. For sure, there are activities which are by nature difficult to include in a model, in whatever model. I'm relating to scope 3 about product use, product disposal, and so on, because it really depends on the consumer habits. So we cannot say we are able to trace the totality of scope 3, but for our situation in this case, most of scope 3 emissions were related to purchasing, so to the milk production, for sure. We achieved strategic improvements both on financial and environmental performance. Those improvements are not ready to be implemented at day 0, but they need to be structured along a long-term strategy. So we can achieve those improvements in 5 years. Okay, so we need also to work later on operational processes in order to adjust them to meet the desired outcome of the model. And we also must maximize the opportunities, because by combining all the possibilities among sustainability options over time, we selected the strategy that put those alternatives in the best place in time, okay, in order to maximize our two objectives, so carbon footprint and profitability. Another thing that I found it interesting is that we didn't act on the product side. So we didn't change anything in the product, anything in the industrial process. So in the scope 1 activities of our customers, but we just talk about supply chain decisions. So for example, changing the distribution network, changing the packaging. We also evaluated several other activities, for example, changing transportation modes that later on seem not feasible for our situation, but we just work on supply chain. So by leveraging our expertise on supply chain. And at the very end, another important aspect is that we increase the collaboration among all the actors in the value chain, because the environmental results are systemic and they are shared among various actors. So the company producing yogurt has also done a favor in respect to the milk supplier and the packaging supplier, if we are considering the environmental point of view. Last thing, this is just for any logistics user, you may ask yourself about how it's possible to include shelf life mechanism in anyLogistix without using any logic parameters. So we achieved these difficult results by using time periods and parallel distribution centers with push policies among warehouses and end-of-life collection center. And at the very end, we managed to reproduce the shelf life by considering periods of 2 weeks and by forcing the stock after 2 weeks of permanence in the warehouse to be pushed directly to the end-of-life collection center. So in some way, let's say in a primitive way, we managed to also consider the parameter of shelf life inside our model. And I find it very interesting, especially if you need to use anyLogistix for this kind of activities. So I thank you for the attention, and if you have any question, please feel free to ask. So the first one, you present the product expired and the plastic used. So for what concerns the plastic, so the coefficient of plastic usage, we started from the bill of material. So in the bill of materials, we know that a package of 8 yogurts in jar uses 8 jars, and the jars have a proper weight. So you can also, if you want, direct measure it. So the plastic, we know all the technical characteristics of the plastic, and we also tried to make some communication with the packaging supplier. We had no idea of what could be its environmental footprint, so we relied on LCA analysis and sectorial studies on how could be the average coefficient of emission factor for plastic production in the food sector. So if you later on, I will send you, if you want, the link. You can find all the articles related to this study, and you can find also the references we used. So the various databases we used to retrieve emission factors for the processes which were not covered by any data available in our client. And the product expired, it's very simple because, as I was mentioning, there is this mechanism we put in place, and we also considered not a total shelf life, but just a commercial shelf life. So when you have to do with the retailers, they want that you provide them a product with a remaining shelf life of 20 days, 30 days, depends. So if our product was not matching this requirement, it was considered to be discarded. So at the very end, it could be eaten, but it could not be sold at the retailer shops. So we have to discard it. So I'm going on with the question. What do you mean with positive bullwhip effect? Do you mean that you reduce the days of inventory? No, I mean that the bullwhip effect is propagation of the effects on the upstream level. So we produce a little enhancement of the carbon footprint at company level because we optimize the inventory. And so we reduced the expired products, and this effect propagates in a positive way in terms of emission for what concern the supplier of the yogurt factory, because less expiration in the products means less production of milk. Okay, and since milk has a huge carbon footprint. Milk production has a huge carbon footprint associated with the farming activities. So we produce this bullwhip effect that propagates, let's say, in the upstream level of the supply chain. And then we have another question. How would you model the end-of-life activities such as packaging, waste, processing, and expired product disposal and logistics? I think it's quite technical. If you want to see the details of how we do it, maybe you can write me an email and I will give you all the details about how we manage to include shelf life. I have to state that it was just an experiment. Okay, so it was a mechanism that some way is useful to represent shelf life, but I have also a lot of limitations in terms of entities. You have to duplicate a lot of entities. You have to segmentate your time in different periods, so it's not easy. Okay, for us it worked, but I mean it's not something that could be used in all cases.